All right, we're going to graph one more parabola from standard form. So we have y equals negative 1/2 x squared plus 3x minus 4. Our a value is negative 1/2. Our b value is 3. For fun, our c value is negative 4. We're going to use our axis of symmetry formula for standard form, which is x equals opposite of b over 2a. So we go x equals opposite of 3 over 2 times negative 1/2, which becomes x equals opposite of 3 over negative 1. So inside the parentheses is going to be negative 3. Opposite of that is 3. So x equals 3 is our axis of symmetry. All right, so now we need the vertex. So we're going to substitute 3 in for both x's and solve for y. So y equals negative 1/2 times 3 squared plus 3 times 3, and then minus 4. So y equals 3 squared is 9 times negative 1/2 is going to be negative 9/2 plus 9, and then minus 4. All right, negative 9/2 plus 9 is going to be 4.5, positive. 4.5 minus 4 is going to be positive 0.5. So our vertex is when x is 3, y is 1/2 or 0.5. I'm going to say 1/2. So 3 comma 1/2. So go to 3, 1/2 is right there. All right, so we're a little bit trickier. So now, from here, the a value is negative 1/2. So I know when I go over 1, I'm going to go down because it's negative, and I'm going to go down only 1/2. Oh, that worked out nice. Now, when I go over 2, usually 2 squared is 4. 4 times negative 1/2 is negative 2, so I'm going to go down 2. So you got to be careful because I'm dealing with those halves. So I start at 1/2 positive. So now I'm at negative 1.5. All right. Ooh, without even doing the next one, we know that the y-intercept is going to be where? That's right, 0, negative 4. So my next one, I already know it's going to be right here. That's 3 away from the axis of symmetry. So 1, 2, 3 away the other side. There we go. And then if I go 4 away from the vertex, well, 4 squared is 16. 16 times negative 1/2 is negative 8. So I'm going to go down 8, which would be what? Negative 7.5. So that's like right there. Right there. All right. Let's see. 6, 7.5. Yes. All right. There's my parabola. So yes, it's compressed. So that's why it's a little bit fatter or wider than the parent graph, and it opens down because of the negative a value makes it reflect over the x-axis. There you go. So again, graphing standard form, a little harder than vertex form because we have to find the vertex and the axis of symmetry first. So that takes a little bit of work. Once we do that, then it's just like yesterday's lesson with vertex form using the a value. Now, do you have to use the a value to graph them this way? No. As a matter of fact, I showed you before spring break how to graph these just using a table of values, right? We just pick a table of values from the axis of symmetry, going right or left, three or four values, and find all those y's, and then mirror the other side. But a lot of students I found over the years like this method. Once you understand the a value, this is a quick way to graph versus doing all kinds of substitution work to graph these by hand. All right, hope that helps.